back, future doctors. Continuing in our NEET Triple Test Series. Now let's look at the next question. Okay, right. As you can see here, this is a match. It's just matching list one with list two. Okay, in list one we are having blood groups. Okay, and in list two we are having the corresponding donors blood group. Okay, so basically what we need to do, we need to identify who's the recipient and who could be the donor, right? Okay, so in order to understand, okay, we have a basic concept that is called as Landsteiner's law. So what Landsteiner's law gives us? It is basically on the antigen antibody interaction, right? Okay, so Landsteiner proposed two laws. First law is forward grouping and second law is reverse grouping. Basically these things are not given in NCERT, but I just wanted to share some idea. Okay, so as you can see, this law describes the principles of ABO blood grouping. So law 1 states, if an antigen are nothing but proteinaceous or any sugar molecules, okay, or any glycoproteins that are present on the surface of plasma membrane. Okay, so here if any antigen, say it's A or B, okay, if any antigen is present on the surface of RBC, the corresponding antibody will be absent in their plasma. Okay, what's the reason? The reason is obvious. If you are having A antigen and if you are having the same antibody for the same antigen, what happens? It just comes and bind and triggers some immune reaction, right? So it can lead to agglutination, correct, and hemolysis. Okay, that's a pathological cause. Okay, so basically for a normal physiology, for a particular antigen, the corresponding antibody, okay, should not be present. In simple words, if I have A antigen over my RBC, the antibody against that A antigen should not be present in the plasma. Okay, so same thing applies. The second law is like reverse grouping. So you see, if you are having a particular antibody in your plasma, the corresponding antigen should not be present on the surface of RBC, correct? So let's say we are having antibody against B antigen. That means what should be the antigen on the surface of RBC? It should be A antigen. Getting the idea? So these are the, okay, in NCERT you do not have the term like law 1 and law 2, but basically this is the idea. Okay. So looking at the point, let's say a person having a blood group of AB. In AB blood group, he is going to have both A antigen and B antigen, correct? Because I'll just link this chapter with genetics part, okay, principles of inheritance. There we see that ABO blood grouping is an example for multiple allelism. Yes or no? So basically, these guys, okay, AB, who has AB blood group, right? They have their genetic material has both alleles, that is response for the production of A sugar and B sugar. Basically, these are sugar molecules on top of blood's RBC membrane. So the corresponding phenotype for this type of genotype will be A B blood group. Okay. So what about A group fellows? They can have two types of things, right? One is homozygous A alleles or heterozygous IA and I naught. So both these genotypes can result in the phenotype of A blood group. What about B? Similar, homozygous condition and heterozygous. Since this IO allele cannot produce any polysaccharide, that is glycoprotein on top of sugar molecules, they are considered to be recessive. That is the idea of recessive. Its effect is masked, right? Okay, so you see here we are having B blood group. What about O blood group? It is homozygous recessive, correct? So what are we going to have? We are going to have IO and IO. Okay, so these are O groups. So basically, neglecting that RH factors, rhesus factor, let's focus on only ABO blood grouping. So if you see, so these guys, O blood groups are there, right? They can be universal donors. Why? Because there won't be any, be it antigen against A, antibody against A or antibody against B. It is not going to affect these bloods, right? These RBCs, because it doesn't have any signaling molecules that triggers the immune system. Okay, so these are nothing but our universal donor. What about AB? These guys have both A and B. So what happens? So it is not going to be affected by any of the antibody. These guys are like universal recipient. They cannot donate to anyone. Correct? They can donate to AB blood groups, but these guys can receive blood from anyone because their plasma is not going to contain any of the antibodies be it no antigen A or antigen B. Okay, that is the idea. So AB blood groups are universal recipient and O blood groups are universal donor. Okay, now let's come back to this question. So you see, so A, okay, so we are having blood group and then donor groups. To who all A blood groups can donate? They can donate to A and O, right? So look at the options. You can have two differentials here, right? Because A is matching with 4. Okay. So what about B? B can donate to B and O, yes or no? Okay, perfect. So B is 2, which means now I can surely mark this. In examinations, you are going to get only 60 seconds. Okay. So my advice is once you're getting two options and you're having that, there is no other option that is matching your response. Just mark this as 4 and just move on to the next question. But for sharing some idea, okay, I'll just proceed to the other things. You see, option C, AB blood group. They can they donate blood? They can receive the blood from AB, A, B, and O, right? So these are the respective donors, yes or no? So C with 2, correct? C with not respect to 2. Why? Yes. Okay. So the option is 2 here. Okay. C with respect to 2. And what is D? O blood group. They can receive from only O. Okay. So the correct response is 2 here. I hope there is no doubt in this case. Okay. So yeah, I hope this solution helps you in any amount, in any degree of way. Okay. I'll see you in the next session. Thank you.